Hello there, welcome to the Sleepy Scientist, where curiosity feels calm and science gently leads us to sleep. Tonight's calm story is all about time, one of the strangest things we follow every day but still don't really get. Time flows past us, shapes our lives, and sometimes messes with us, like when we wait for a kettle to boil. But before we explore time's slow and steady path, tell me, where in the world are you watching from, and what time is it right now? It's kind of perfect, isn't it? A video about time, and all of us here in different time zones, meeting at this exact moment in our own corner of the clock. If this feels peaceful, interesting, or just a nice way to rest, please like the video and maybe hit subscribe. That helps others find this little calm space too. I hope it doesn't keep you awake, but if it does, at least you'll learn something cool before you fall asleep. So get comfy, slow your thoughts, and let's begin. Somewhere between seconds and centuries, dreams and morning light, lives the story of time. Time acts strange, right? 10 minutes stuck in traffic feels endless, but 10 minutes doing something fun disappears fast. But clocks move at the same pace, second by second, minute by minute. Why is that? The answer starts not with science, but with your brain. Your sense of time, when things begin or end, is very flexible. Psychologists call it subjective time. It's changed by attention, feelings, and memory. So how you feel time isn't always how it's really passing. Think of waiting at the doctor's office. The walls are dull, the magazines are old, and the clock ticks super loud. 5 minutes can feel like 30. That's because your brain has nothing to do, so it starts counting every second. But when you're chatting with a friend or deep in a great book, your brain is busy and not watching the clock. Suddenly, time flies. That's called the flow state, a term from a psychologist named Mihai Csikszentmihalyi. In that state, your sense of time fades while you stay focused. Also, when you try new things, your brain works harder to remember. Later, it feels like more time passed because there's more to remember. That's why summer as a kid felt so long. You were always learning new stuff. But when you're older and days repeat, your brain saves less detail, and time seems faster. Emotion matters too. Fear or stress makes time feel slower. Happiness makes it feel faster. In scary times, the brain may store more details, so later it feels like it happened in slow motion. People in accidents often say time slowed down, but it's just the brain recording more. And yes, boredom really does make time crawl. When bored, your brain's inner clock speeds up, making you feel every dull second. It's like a drummer in your head tapping non-stop. Language and culture change how we think of time too. In English, we treat time like money. We spend, save, and waste it. But some cultures see time as a space, not a line. Some even point behind for the future and ahead for the past. Total opposite from what we do. But do we have an inner clock? Kind of. Our bodies follow something called circadian rhythm, a 24-hour cycle that controls sleep and body stuff. That's like a daily timer, not a stopwatch. For shorter times, the brain uses a system that acts like a mental stopwatch. It involves parts of the brain like the basal ganglia and cerebellum and counts tiny pulses to guess how long things take. But we're not great at it. If you're multitasking or emotional, your time guesses get worse. There's also the return trip effect. Coming back from somewhere feels quicker than going, even if it's the same time. That's because your brain already knows the way home, so it pays less attention. And of course, we can't skip the snooze button. Somehow, those 9 minutes feel shorter than any others. There's no solid science yet, but it's probably because your brain is groggy and not tracking time clearly. So what is time, really? It's not just a clock. It's how we feel, how we remember, how we focus. It changes with mood, age, even what language you speak. It races when we're happy, drags when we're scared, and sometimes disappears. Science may one day explain time fully, but our experience of it will always stay personal, messy, odd, and fully human. We've tried to measure time forever, from sundials to atomic clocks, always trying to catch this invisible thing and put it in order. Let's go way back. First, people looked to the sky. They watched the sun rise and set, saw the moon change, followed the seasons. These were the first clocks, no batteries needed. Around 1500 BCE, the Egyptians made giant sundials using tall stone pillars. The shadows moved and showed the time, though hours changed by season. It wasn't perfect, but worked well enough for farming and prayers. Next came water clocks. Egyptians, Greeks, and Chinese all used them. Water flowed from one bowl to another at a steady rate. These clocks even worked at night. Some had gears and figures that rang bells, kind of like the first smart devices, but with water. In Mesoamerica, the Maya made amazing calendars. They tracked moon and sun cycles for thousands of years. Without metal tools or animals, they built time systems that were cosmic. In Europe, by the Middle Ages, mechanical clocks appeared. Big ones in towers rang bells on the hour. They had no hands or faces, just chimes to tell monks when to pray. You could say monks were the first alarm clock users, though much calmer than us. Around the 1300s, engineers made the Verge escapement, a gadget that controlled how energy was released. This made smaller, more reliable clocks possible. Later, clockmakers added hands and dials so people could see time, not just hear it. Timekeeping sped up. By the 1600s, Dutch scientist Christian Huygens made the pendulum clock, which was super accurate. Now people could count minutes without drifting by hours. When sailors needed to know their position at sea, time became vital. John Harrison, an English carpenter, invented marine chronometers, clocks that worked at sea. His H4 model changed sea travel forever. In the 20th century came quartz clocks. Quartz vibrates at a steady rate when charged. These clocks were cheap, small, and precise. But if you want the most accurate time, go atomic. Atomic clocks use atoms like cesium. One cesium atom vibrates 9,192,631,770 times per second. That defines a second. Atomic clocks only lose a second every 100 million years. Today, we use them for GPS, the internet, banking, and more. Without atomic time, maps would be off, bank systems would fail, and Zoom calls would be chaos. Still, time feels personal. We can measure it, but we all feel it differently. So why did we start tracking it? Maybe for farming, trading, praying, or maybe because we love rhythm. The steady tick gives us comfort. It brings order. It says, "You're here now." Time used to rise with the sun, follow birds, and drift with bells. Then Isaac Newton came along. He believed time was a steady flow, ticking the same for everyone. To him, time and space were like a stage. The actors, planets, apples, everything, moved, but the stage didn't. Newton said time flowed equally for all, always. His idea, absolute time, was the heart of physics for centuries. Drop an apple today or tomorrow, his math would tell you where it'd be. This steady time helped science a lot. It let people sync clocks, plan events, and predict motion. But it also assumed time was real on its own, even if nothing happened. Philosopher Leibniz disagreed. He said time is only a way to compare changes. No events, no time. For him, a clock in an empty universe meant nothing. Newton disagreed. He believed time moved on, event or not. His model, called classical mechanics, worked very well for a long time. It helped with planets, pendulums, and even juggling. Newton's time gave us progress, better clocks, trains, and tools. But in the 1800s, strange things with light showed cracks. No matter how fast you moved, light's speed stayed the same. That didn't fit Newton's world. This stayed a puzzle until Albert Einstein entered. But that's a story for next time. Newton's time shaped science and culture. We still speak of saving or wasting time. We run on it daily. And for most things, baking, traveling, it works. But when things go really fast or involve big gravity, Newton's time doesn't hold up. Still, his view gave us a solid base. He made time feel real and useful. But time has layers, and Newton's version is just one. If Newton saw time as a smooth river, Einstein said it was more like a stretchy trampoline. That sounds funny, but it's not far from the truth. In the early 1900s, Albert Einstein changed everything. He introduced a theory called relativity, and it came in two parts: special relativity and general relativity. Both changed how we understand time, and neither felt normal. Special relativity came first, in 1905, when Einstein was 26 and working at a patent office. He said the rules of physics are the same for everyone, and that the speed of light is always constant, no matter how fast you're going. This caused a big problem for Newton's idea of steady time. In Newton's world, everyone agreed on when things happened. But in Einstein's world, if two people are moving at different speeds, they might see events happen at different times. This led to a strange idea called time dilation. It means that the faster you move, the slower time goes for you, compared to someone who isn't moving. If you got on a spaceship and flew close to the speed of light, your clock would tick slower than one on Earth. You would age more slowly. Your hair would grow slower. You could leave for a trip and return younger than your twin. This isn't just sci-fi, it's real and proven. In one test, scientists put atomic clocks on airplanes and flew them around. The clocks on the planes ticked slower than the ones that stayed on the ground. Not by much, but enough to show it works. There's also a famous example called the twin paradox. One twin goes on a fast space trip, the other stays on Earth. When they meet again, the space twin is younger. Not because of magic, because their time moved slower. But speed isn't the only thing that affects time. Gravity does too. In 1915, Einstein added gravity to the mix and created general relativity. He said gravity isn't a force pulling us down. Instead, mass bends space and time. Picture spacetime like a soft blanket. A heavy ball, like a planet, makes a dent in that blanket. That dent is gravity. Time also bends with it. That means time moves slower in strong gravity. If you're near a black hole or even at the bottom of a mountain, time ticks slower for you than for someone higher up. It's not just theory, it's been tested. 2 atomic clocks, one at the bottom of a mountain and one at the top, ticked at different speeds. The lower clock moved slower. Even a small height difference can change time. That means your feet are aging a bit slower than your head. This effect is called gravitational time dilation. It sounds weird, but it's real. Time stretches and squeezes based on how fast you go or how much gravity pulls around you. This leads to mind-bending stuff like time travel, not the kind with machines and flashing lights, but real travel through time using speed and gravity. In space, astronauts on the International Space Station age just a little slower than us on Earth. Not enough to notice, but it proves Einstein was right. His theories completely changed physics. They led to GPS, black hole science, and a better idea of the universe. Without relativity, GPS on your phone would be wrong. The satellites orbit Earth, and time ticks differently up there. Scientists have to adjust for that or your map wouldn't work. So, thanks to Einstein, we now know time is not the same for everyone, everywhere. It's flexible. It bends. It moves slower in speed and gravity. It's not a steady river. It's more like a fabric that stretches and warps. Strange? Yes. But it helps explain how the universe really works. And it shows us that time, even when measured by perfect clocks, is still a little bit wild. So now we know time can stretch, slow down, or speed up depending on how fast you're moving or how strong gravity is around you. But what about the future of time itself? Scientists are still exploring what time really is and where it comes from. Some theories suggest time started with the Big Bang, around 13.8 billion years ago. Before that, time may not have existed at all. That idea is hard to imagine, but in science, not everything fits into our daily experience. Some physicists think time is just another dimension, like the 3 dimensions of space, up and down, left and right, forward and back. If that's true, then time could be something we move through, just like space. Others believe time might be an illusion, something that only exists because we remember the past and expect the future. In that case, maybe only the present is real. It sounds confusing, but even top scientists debate what time truly is. There are also ideas about time loops, where events could circle back and repeat. Some theories in quantum physics and string theory suggest the universe might allow for time to twist or fold. No one knows for sure, but it shows just how mysterious time remains. One thing we do know is that time is connected to everything: space, gravity, matter, and energy. When something changes, that's how we notice time passing. A clock ticks, a leaf falls, a star burns out. Each of these is a tiny sign that time is moving forward. But does time have to move forward? That's another big question. Most laws of physics work the same forward or backward. If you watched a video of planets orbiting backward, the math would still work. But in daily life, time feels like a one-way road. We remember the past, not the future. Eggs break, but don't unbreak. Smoke rises, but doesn't gather back into firewood. This feeling of direction is called the arrow of time, and scientists think it might come from entropy. Entropy means disorder. Over time, systems tend to become more disordered. A clean room becomes messy. Ice melts into water. That rising disorder may be why time feels like it only moves forward. It's like the universe is winding down, and we're moving with it. Still, we don't fully understand why time has this direction. It's one of the biggest unsolved mysteries in science. But no matter what time is at its core, we know how it feels. We feel it in birthdays, in seasons, in the way shadows change. We hear it in ticking clocks, feel it in heartbeats, see it in growing children. We live inside time like fish live in water. It surrounds us, shapes us, and moves with us. And for all our tools to measure it, watches, calendars, apps, time still feels personal. It drags when we're sad, flies when we're happy, pauses in moments of awe. So maybe time isn't just science. Maybe it's also feeling, memory, and meaning. The past lives in our stories. The future lives in our hopes. And the present, that little space between the two, is where we truly exist. Whether it moves like a clock or flows like a river, time connects us all. And that, more than any theory, might be the most human truth about it.